Hi, Mr. Finney. This is George Amengold, and this is the presentation for the Graphics1 Project2. First of all, I'd like to thank you for solving that issue with the shader and the texture unit. It's all working now in the NVIDIA card. Okay, let's get right to it. Just an overview of your requirements. This is a short description. Do you like base directional point and spotlights, 2D texture in a skybox with a cube texture, multiple shaders, interactive control of camera and lights, transparency, and here you describe in more details what you want. Okay, so let me run the thing. I know you have a lot of assignments to see, so I want to be as short as possible. Here it's calculating the AABBs, so it can take a longer, also because I'm using the OBS to record the presentation and takes more time. Okay, this is our scene, and you can see it's kind of dynamic. I just stopped the DeLorean, and now I'm moving the DeLorean with controls that it's described in the README file. The interesting thing for the DeLorean is that all the model has its own colors. It doesn't have any texture on it. So it's just to show that for this shader we can load texture models without any texture with the colors in the model itself, and models that we can set the color in the diffuse color. Okay, so for the DeLorean, just show you here the apply file. So here we have the information for the vertex, the normals, and the colors, all here. Okay. And you can also see in the scene we have two helicopters with some effects here. Let me select this helicopter. Okay. I can select all three objects for this scene with number 1, 2, 3 and move around. So here you can see the reflection, it's working. It's reflecting the sky map. Okay, and you asked for a lot of lights and some kind of interactiveness with the lights, so I thought of doing this. So you for the light in front of the helicopter, we have you can see here we have a spotlight. So you can see by the shape of the light, it's kind of 45 degrees to down to the front too. So let me get closer to it. Okay, so we have a spotlight that is illuminating this building, and we also have for each helicopter 4 lights. And I created those balls and inverted the normals so we can see where the lights are. See? we have red lights on the tail and in this left wing, and on this green, the right wing, we have a green light. You can see that is reflecting on the fuselage of the helicopter. Okay, and you can see also that we have this specular working. You can see kind of a reflection of the green lights on the fuselage. This is the specular working, it's not the reflection. You can see the other side too. Okay, so we have I think 16 lights for this scene, including the lights for the helicopter. We have the lights for the DeLorean too. Where is it? There. Yeah, I'm a big fan of Back to the Future. And stay tuned for the graphics. I got this thing texturized, so looks pretty awesome. So we have for the DeLorean all Omni lights, or point lights. We have 4 in the wheels, bluish, and we have 2 here for the front of the vehicle. Okay, and we have the sun over there. I put a light simulating the sun, so you can see that it's kind of simulating a dawn kind of light, and the angle it's right with the sun. Okay, in all models, here I have a huge city, as you can see. We even have clouds. I'll get to that in a bit, because I have to talk about transparency. And all those models are loaded by JSON files for the meshes and for the placements, and also the lights are also loaded by JSON files, and the camera position. Let me show you. So here, those are all the models that are being loaded. Okay, they are very complex. For instance, this one that represents the sides of the buildings. We have 211,000, almost 212,000 vertices. Okay, and by the sides you can see here the curves. It's very complex too. Almost 200,000 vertices, sorry. And here in this JSON file, I load all the meshes. So let me show you. Say I want to show just some. Even I created this kind of comment token, so you can comment lines for using later. So let's see here. I want to not show this curves, just this. Save the file. And those meshes are not being loaded anymore. Let's just wait for it to calculate the AABBs and stuff. Here. As you can see, without any hard-coder or stuff, without any recompilation, we just loaded different meshes. In this case, we didn't load. Okay. And another thing, for the JSON files, let me get this back. I have also a JSON file to load the scene. Here we can change the camera position, okay, even the orientation, X, Y, and Z, and have some kind of template here so we can just copy and paste. And this block, I'm loading all the game objects in the scene. So you can see the skyboxes here, the facades, the roofs, asphalt, concrete, all the stuff are being loaded here. Okay. And here, in the last part, we're loading the lights. Okay. So let's say you want to change some parameters here. For the sun, let's say that we want the sun shining more. Let's stop and load it again. Because we have more models now, and also we are recording and get some processor power from the calculation, so it's taking longer. Okay, so as you can see, the sunlight is brighter. Okay. And now I want to talk about the transparencies. As you can see here in this model, they have those helicopters. They have 3 textures: the diffuse texture, the reflection texture, and an alpha texture. I can show you here. See? Let me see if I can open it. This is the diffuse map, and alpha here, and the reflection. All working together to get this nice effect of the fuselage and the windows. And we can manipulate the object in all axes local access. This is not for this. They are not being governed by Newton forces. Just displace it. But for the physics, they are being governed by Newton forces, as you asked. Okay, so as you can see, let me put the texture of the helicopter. What you see here, it's a transparency, and behind it you can see there are also clouds that have transparency. Okay, and they've been rendered in order from back to front, as you asked, so you can avoid the effect of a transparency get erasing in other clouds. So here you can see that you can see the clouds behind it, and if I change the position, and look the other way, okay, so it's working. It's being sorted for each frame. It's being sorted and in the right order. Okay, so for this I created this transparency manager here. Just easy on the machine here. Just a second. Get this value back. Okay, so I created this class to manage the transparency, and this function sort the objects. Okay, it's a simple sort here, and I use this compare function that calculate the camera position. Okay, and I have those functions in the camera. This camera I created a while ago, and it has movements like you have follow camera, you have free camera, and it's moving around its axis. Okay, but it's not important now. And here I sort in the draw call. I have two kinds of objects: the objects that are regular objects and doesn't have any transparency, so they're being drawn here. Okay, and here I draw only objects that have transparency, and I get to sort them here by the transparency manager. Okay, and okay, so let's see what else you asked it. Need to load the number of objects. Mesh in the scene must include normals, materials. Okay, makes sense. The description of the scene, models, location. So the description of the scene are all being loaded by the JSON files, as you asked. Okay, not just randomly assigned materials. Different shaders must be large of number of objects. There are more than we have in Project 2. As you saw, we have a lot of objects, and geometry must have something more lights than Project 1. Have 16 lights. This thing has to make sense. Okay. So for the shaders, you asked it here. That we could have a Uber shader. like only one shader, and that was the approach. So let me show you the shader here. It's of course your shader modified, and what it can do. So this is the GitHub page for the project. Okay, it can handle objects without textures, with colors in the apply file, as I showed you a while ago. Objects without textures with the color indicated as the diffuse material. Textured objects without alpha, textured objects with alpha, textured objects with alpha and reflection, and skybox objects. So all those objects can be rendered together, and the shader does the job. Okay, so what else? Let me just review the grading scheme, so to make sure that we cover everything. Multiple amounts of blend transparency, different variations between transparent and opaque. And as you saw in the clouds, we have this variation. So they are not all white or black. There's a gradient of transparency. And for the tree too. Okay. And sorry. Transparency, multiple objects, so they must be drawn last and sorted from back to front relative to the camera, as you just saw. Here, discard transparency present. Okay, let me show you something. For the trees, as we have a huge amount of trees, and to be easy on resources, it's only one object. It's here, this mesh, sidewalk tree. Okay, it's only one object, two textures, a diffuse and a transparent texture, and it would be impossible to sort them, right? Because they have, it's all it's not only one tree. All those trees in the city are only one object. So how to sort it? That's where we use discard to sort them. To just discard the transparency pixels at some level. As you can see, there's no problem with the transparency here. You can see through the trees, okay? And in the shader, we used the discard. I used this variable, the uniform variable, to see if that object have a discard option, and if they have, I discard like 50% for the color, I discard and assign here. If not, if it's a regular alpha like the clouds, using the material diffuse, and the clouds are being sorted, right? Okay. What else? There must be different textures An example of trivial combining. Okay, we saw that. More involved combining. I think we have this in the helicopters because we have 3 textures working together. Okay, for the debug information, where are the helicopters? Here, let me grab this helicopter here. Number 1. Okay, for the debug information, if I press L, it's active, but it will only render the debug information if I'm inside the ABB, and we only have ABBs on the limit of the meshes and for the size of the ABBs. So let me show you here. So this game object is inside an ABB, and inside that ABB we have those triangles. They are being lit, and this is to show where the calculations for the physics will get place, only on those triangles. And as you also can see here, we have those triangles getting out of the ABB, but this is just because it has part of the triangle inside the ABB, so it had to be part of the calculation, of course. And I have the normals here. You can see the normals in blue. Let me get closer. So you can see the normals for the faces. They are in the centroid of the triangle. And if I move the helicopter, here you can see that other geometry are being lit. Okay. These are the debug information. Okay. So if I press L again, they gone. On, off. Okay. This is a number of models, this is a number of variation, iterative camera, external configuration file, this thing has to make sense. Okay, Mr. Feeney, thank you for your time. This is the end of this presentation. And I would like to thank you again for your help, and I hope you like it. Bye-bye.